All right, so our second example, guys. We are looking at a cylinder. It's a cylindrical can that is 1 liter, and we're trying to find the least amount of material. 2 words. What am I doing? Surface area, but we're trying to minimize surface area. So 3 words. My bad. So minimize surface area. Let's go ahead and write that down. Minimize surface area of this can. So if I were to cut this can and kind of fold it out, the top part, if you know it, is 2 pi r, and the side is h. You with me? So the surface area is going to be, the lateral surface area is the area of this cross-section rectangle. And then we're going to add the area of the top with the area of the bottom. You'll see what I'm doing? Surface area. So I'm adding how much? 2 pi r squared. So pi r squared is the area of each of those circles, and there's 2 circles. So it's 2 pi r squared. Okay? So now, let me ask you, can I write this like that right now? No, because I have h. And I can't write it like h right now because I have r. So that's why we have this secondary equation that we can find, or that we're given to, or given, where we can substitute r into h or h into r. Okay? What equation can I create from what you see right now? Volume, right? Okay, so volume, here we go. The volume is pi r squared times h. Thus, h is equal to the volume over pi r squared. They gave us the volume of 1. So what I can do is I can take this h value from our secondary equation, and I can plug it in substitution-wise right here. So that then I can put it as in terms of 1 variable. So that's the cool part of this unit versus related rates. You don't have to have 2 different variables where you do implicit differentiation. Get it all in terms of 1 variable and then derive. That's the easy part. All right, here we go. So I'm going to change this h over to 1 over pi r squared. And here's my equation that I'm trying to minimize. I'm going to use first derivative test, and I'm going to try to see when does the derivative change from what? Negative to positive. This is what I'm going for as far as finding on that number line. Any questions? All right, so if this was by hand, we could simplify, and I'm going to do a little bit with you so that you can get accustomed, because there's some by hand. Those would simplify out to 1. One of these would simplify to r on the bottom. So you could have the simplified version that looks like this for the position function, which is the surface area of the cylinder. Okay? Now it's been a while, but 2 over r is the same as 2r to the negative 1. So if I derive this by hand, I would get negative 2 over r squared plus 4 pi r is equal to the derivative function. What have you been doing with homework, and what have we been doing in notes when it comes to finding critical points? What have we been doing? Set the top equal to 0 and set the bottom equal to 0. You all with me? So by looking at this, if I did this by hand, I could multiply it by a form of 1 so that I have common denominators. Okay? And then I can go r squared is my common denominator. The entire top would be a negative 2 plus 4 pi r cubed. And I could set this equal to 0. Now, when I'm finding with the calculator, when I set it equal to 0, the derivative, all I'm doing is finding this. But the reason why I just showed you how to do this is because I want to make sure you understand that you also have to set the denominator equal to 0 if there's a variable there, because that too is a critical point. Okay? So with me, what we're going to do is we're going to go through with the calculator, and I want you to see what this looks like. Okay, here we go. And actually a student, Hayden Miner, I'll give him credit, he helped me out as far as how to do this quickly with the calculator that I want you to actually use. Let me show you what that looks like right now. It was during second period today. All right, here we go. Between every problem on your test, I think it would be very wise for you to press menu 1.4, which clears all storage, and then menu 1.5 to have a nice clean slate. Otherwise, if you store something and forget what you stored, it will mess things up for you, okay? Here we go. So let's go ahead and store our position function. Control divide 2 over r plus 2 pi r squared is going to be stored as, this is surface area, I'm just going to put it as a of r. To me, I don't want to put SA of r, too many variables. And then I'll press enter. Okay, here we go. I'm going to take the derivative, so derivative in respect to r of my saved a of r function. And I have this. Right now I have two pieces. Okay? But I'm telling you, we need to get our derivative to one huge, like a simple or improper fraction form, where there's one numerator and one denominator. And Hayden showed me this today. Menu 3, 9, 4. Common denominator. And then just scroll up, press enter to copy that down, and it does it for you. So it did what we just did by hand very easily and quickly with the calculator. So this tells me I need to find when the top is 0 and when the bottom is 0. You with me? So here we go. Menu 3.1. I want to solve, press that key next to 9, when the first derivative in respect to r, and my stored function is a of r, kick out 1 parentheses, and set it equal to 0, and look for all the r's when that occurs. There's my, okay, let me show you real quick by highlighting it. Ooh. So this is when the numerator piece, is equal to 0. What we just found, guys, was this one, which if you go to your calculator right in front of you, let me show you real quick. If you go up real quick to your last answer, this is how you can get more decimals. People were wondering that earlier. Just go up to it, click enter, and it'll show and display more decimals. So 541,926. Okay, 541,926. We should always do how many decimals throughout a problem? 6 at least. And then only round the answers to what? 3. Okay? Is there another critical point that I can put, bless you, on this first derivative sign text? 0. So there's actually 2. Okay, here we go. So we're going to test 3 intervals. We're going to test maybe like -1, a positive, like 0.1, and like a 0.6. Okay? So here we go. Let's go back to our calculator. We'll press menu 4.2, derivative at a point. What's the variable? R. Nice. What's the value? -1. We're going to do the first derivative of a of r, because that's our position function we stored, and you see we get a negative. Get in the habit of control enter. Now look, we don't have to go through all that again. Just look. Click up twice, press enter to copy what you did, and this time let's do like 0.1. you still have a negative. If I go up twice and I press enter to copy it, and I did this time like 0.6 or even 1, you see a positive. So I've just completed the sign test of 3 different intervals with the calculator very quickly, and I got something that looks like this. The negative, negative, and a positive. And this is what I was looking for, because I was trying to minimize. Yes?
How is 0
Critical point, 0 is a critical point because critical points are when the numerator and the denominator are equal to 0. Because remember when the numerator equals 0, that's when f prime of x is equal to 0. This comes from the numerator. And when f prime of x is equal to undefined, which is the definition of a critical point, this comes from when the denominator is equal to 0. Okay? So now, any questions before we go for our answer? So we will say this value is an R, and we're trying to find the least amount of material. So now that I know my at moment, this is why the at moment was so important way back when I was trying to tell you at the very beginning of the year. This at moment, we're just going to put right there. Not in the derivative, but in the position function, because that tells me what is the actual surface area. Okay? All right. So here we go. Let's go over to the calculator, and I'm going to put a of that number, but to 6 decimal places. Okay, so you can come up here, grab this, and then you can kind of scroll back. You will have to take off this R equals, and then press Control Enter. And there's your answer. To 3 decimal places, you're going to write 5.536. I'm a rounding kind of person. You can truncate it and put it as 535 if you want. But nonetheless, you can only be 1/1000th of a point off to get that credit for the answer, okay? All right, so let's go back. Let's finish our justification and whatnot. So we'll say, per first derivative test, the surface area is minimized, so we could say minimum, absolute minimum, surface area equals the 5.536 what? Units. Good. It didn't tell us any units. It didn't say centimeters. Some of you know that centimeters cubed is dealt with liters. I don't need you to remember that. If it doesn't give you units specifically, just put UN for abbreviation. And we're going to put units squared. Okay? And we're going to say when R is equal to 0.542 units. And you can spell this out if you want as well. And H is 1.084. Guys, where did I get H from? Yep. So my secondary equation that I used to write it all in terms of one variable, I'm just going to plug in the at moment that I found here, right here. I just have to be careful that I plug in how many decimals when I plug them in. At least 6, or you will be off on your answer, okay? At least 6. And then once you get your answer for H, whatever it is, then round that or truncate it to 3. Okay? And then you're going to finish this justification by saying because there's only one critical point. Only, so we can say there is only one critical point, which is in this case R is equal to 0.542. it being the only one, there's no other place that it can be the absolute. So you can bypass doing candidates test, which is more time consuming, if and only if you mention that there's only one point where this is occurring. Any questions, guys, from everything we've done?
Was it just a coincidence that H was double R?
It was just a coincidence, yes. Yeah. And there's relationships that exist that way for sure. Golden rules, golden ratios, all kinds of other stuff. Any questions? All right. So let's go ahead and do the next one.